thnx. The first part of the question is straightforward. Work out the probability that both Helen and Anthony pass the medical, which everybody's got. That's the next part. 0.9, no point.
1.
0.7, no point.
3.
0.7, 0.3. Now, part B is part C is the question that we're interested in. Work out the probability that only one will pass, which means Helen will pass the first go and Anthony will fail. Or we said Helen will fail and then Anthony will pass. So the calculation is as such. Probability of pass and probability of fail, or probability of the fail and the probability of the pass. So let's look at the numbers now. So Umar, 0.9 times by 0.3. So 0.9 times by 0.3, or means add. The next one is going to be 0.1 times by 0.7. 0.1 times by 0.7. So 0.9 times by 0.3 gives you 0.27. 0.1 times by 0.7 will give us 0.07. And we add them up, that gives an answer of
0.34.
0.34. Is that what you got?
Yeah.
Done.
Yeah.
That's that question done. Okay, here comes the next question. Now we need to do the next question together, nice and slowly. Question number 8, I'll put that in for you. That's for any of you who are budding A-star students. Part C's anyway. Okay, right, let's get rid of this up on the board. Okay, let's move on to the next question. Now the next question, I have a feeling. Oh, it is on there. That's good. Alright, here's the question. Let's make it a bit. Where's the mouse? That's better. Right, question number 7. Let me just quickly check that we got a good image. Oh, that's nice, but it's just like it's chopped off the top bit. That's better. That's all in. Yes. So make sure I don't go off the bottom of the. There are 3 red sweets, 2 purple sweets, and 5 orange sweets in a bag. Georgina takes the sweet at random. She eats the sweet. Okay, what does that indicate to you, Mr. Ramiz? If she eats the sweet, that means she hasn't put the sweet back. So it's going to be probability without replacement. Okay, so she's eating the sweet's gone. Yeah, she's eating the sweet. She then takes another sweet at random. Work out the probability that both the sweets are the same color. Good thing it's not one of my other students, but just eat the whole bag, it won't go. There won't be no probability question at all then. Okay, work out the probability that both the sweets are the same color. So what are we looking for? We are looking for the probability of a red sweet and followed by another red sweet. Work out the probability that both the sweets are the same color. So both sweets are the same color. Okay, so it's going to be, Mr. Ramiz, this is one idea, one solution, or what's another way of getting the same color?
2 papers.
So probability of purple and the probability of purple. Okay, or there's one more way.
Of orange.
Okay, let's have a Afira. We can have 2, what are the sweets we have?
Probability of orange.
Probability of an orange
And
the probability of an orange. So now this is the idea, this is the important part of the question, is you in your head in the examination realizing it's a red and a red, or a purple and a purple, or an orange and an orange. Because them are the 3 colors that we have in the question. Slide down a bit more, 3 more rows. Now let's have a look at these calculations now. First of all, Mr. Idris, we have 3 and 2, that makes 5. Add another 5, that gives us 10. So probability of my first red is going to be 3 out of 10. And means times. The probability of my second red after you've eaten the first one, what is it? 2 out of 9. Excellent. Okay, what did we say the O means? Okay, now probability of purple and purple is of IFRA. The first purple probability is going to be 2 out of
10.
And the next one's going to be
1 out of 9.
1 out of 9. Why? You've eaten one sweet, so that's gone down. And you've eaten one of the purples, that's gone down. Now let's have Mr. Umar. Orange sweets, how many are there?
5.
5 out of?
10.
And if you eat that one 5, now I'll have how many orange ones left?
4.
4 out of 9. Lovely. Okay, so that's what the calculation looks like so far. Samia, are we still in video? Okay. Long time after I've gone off.
No, you're fine.
So yeah. Now, I've got enough space here. Can you see my hand in this video?
Yeah, I can see a couple of fingers.
Oh, so we're running out of space in the video. Okay, now.
Can't make another one.
That's better. A lot of space there now. Okay, right. Let's get cracking with this now. Okay, are we happy with how we structured it out? So 3 times by 2 is?
6.
6. 6 out of 10 times by 9 is?
90.
Let's leave that for the moment. That counts for the moment. Let's leave that out. Add 2 times by 1 is?
2.
And 10 times by 9 is?
90.
90. Idris, are you with me?
Yeah.
5 times by 4 is?
20.
And 10 times by 9 is?
90.
90. Now, the good thing about this is all the bottom numbers are the same, so we can add the top numbers. So 6 add 2 is?
8.
8 add 20 is?
28.
28 out of 90. Okay? That is the probability of getting both the sweets of the same color. Now, could we cancel this down?
Yeah.
Okay, they're both even numbers, so you can cancel them down at least by 2.
14 over 4.
So if you divide this by 2, so that will give us
14.
over 45. Okay, Samia, have you got this red part into the end?
Yeah.
Good. Done. Okay. If you put that down as the examination answer, the final answer, that's still good. Okay. Unless they sometimes they specifically specify that please cancel it down to the lowest possible fraction. For both of these answers, this one and that one's good, but we're going to stop there. We're going to simplify. Are we happy with that question?
Yeah.
So this question is a bit more of a thinking question. Do we need to draw the tree diagram for this question?
No.
No, just think it out. So both red, both purple, both orange. So it's either this combination or that combination. So it's more of a writing experience. Okay, we're happy with question number 7.
Yeah.
Okay, question number 8. We've done questions like that. I want to move on now to the.
So what can you see? 8 things.
No. I'll leave that for you guys to do. Okay, we'll do 8 and 9 in a bit. Okay, exactly one game. Should we do 8? Let's do 8 up to B. Let's do 8 up to B.
No, do C.
No, see, it's for you to do. I'm not doing it. I told you, it's for those of you who want to go to the next level up.
Can you do so?
I should be able to do that. There you go. Right. This question's got that word in it.
Exactly.
Work out the probability that Sheila will win exactly 1 game. That's why I want to do that question. Here we go. What's the matter? Okay, that's good. That's lovely. Zoomed out a bit of the camera. Right. Okay, so this is question number 8 on your exam paper. So we got 2 events, we got darts and dominoes. So Sheila winning darts and losing. Sheila winning the dominoes and losing, winning and losing from here and from there. Right, let's quickly fill in the table and see how we do that one exactly. We've done questions on this before, but let's do this last one now. So Sheila wins is 3/4, so the probability that she doesn't win is?
1/4.
She wins the next game is 1/3, so it's going to be?
2/3.
And just copy them down. So work out the probability that Sheila wins exactly 1 game. Now, a common response in the examination paper is this. Okay, listen, watch carefully. Students in exam papers have marked before in the exams in the general, when they see the word exactly one game, they do this. Oh, yeah, wins one game. Yeah, finished. There's my answer, 3/4.
No, you wrote it down.
Wins one game.
Bloody
Because they look at the word exactly one game, Ramiz, and they literally do the one game win and stop. And I've done the question.
That's stupid.
And they feel that they've done the question, and then that's a common answer for that type of question. But that's not the answer, obviously. Right, so exactly one game means that she wins one game, but the second game she must lose. Win and lose. Or she's got to lose first and then
Wait.
win it. So the probability of winning and the probability of losing. Now, because it's going to be this route or this route, put the O in there. So it's going to be losing, doesn't win, losing and winning. Let's put the numbers in. The first one is going to be 3/4. 3/4 times by 2/3. And means times. The word O means add. Probability of losing is 1/4. And the probability of winning is 1/3. And means times. So probability of losing and winning. Now let's work these ones out. So that'll give 3 down by 2 is going to be 6 over. And that's going to be 1 over 12. 6 over 12 and 1 over 12 will give us
7/12.
and that's the final answer for that part of the question. Okay, now without any further delay, I'm going to leave part C for later. That's like a teaser for you guys to see if you guys can do it. We're going to move on to skip number 9. Now we're going to go on to
10.
number 24. For number 24, I'm going to load up some pictures of that.
They got like at the back the same.
Oh no, that's right. Do you know why? After I've done, you do. Well spotted. Mr. Umar spotted I've duplicated the last 2 pages, that's right. So after I've done the question, you can do the questions. What do you think, you're just going to go home, huh?
Yep.
You're going to make me sweat? So there's pools of sweat on the floor. You go home and you feel half a stone lighter. Okay, I don't think there's any more of these. That's it, that one's finished. Right, okay, I need to load up my pictures, which I've... where are my pictures gone? That's a video. Okay, oh, here they are. Just give me one moment, folks. It's in here somewhere. My documents. Oh, there it is. Okay. I think that's the question. Right, let's get this over to the projector. Okay. It comes out, well, you can see the question, can't you? It just comes out a bit dark on the projector. It's quite bright on the original image. Okay, right. Let's see. Does it come out? Can you actually see anything?
Yeah, you can.
You can? Okay, well, this will do by speaking about it. Question number 24. Question number 24. There are 3 different types of sandwiches on the shelf. There are 4 egg sandwiches, 5 cheese sandwiches, and 2 ham sandwiches. Erin takes at random 2 of these sandwiches. Like at the probability that she takes 2 different types of sandwiches. Now, for this kind of question, we can do a possibility space diagram to show us what the possibilities are. So let's have a look. Okay, right. So here's my first sandwich. It can be an egg sandwich, or a cheese sandwich, or a ham sandwich. And the second one could be an egg, a cheese, and a ham. Okay. And the question was, work out the probability that she takes 2 different types of sandwiches. Which ones are the same sandwiches? You've got to loosen it.
Egg and egg.
You've got to loosen it to move it. Don't do that either.
Cheese and cheese.
Yeah? You don't break the stand. Now loosen that thing and then you move the camera. So these are the same ones. It looks like a grid. Are you familiar with this? Look. Egg and an egg.
Yeah.
Cheese and cheese, yeah? Them are the same ones.
And this one will be egg and cheese.
Okay, they've asked you to work the probability that she takes two different types of sandwiches, which is going to be everything else. So they want you to work out the probability of egg and cheese. They want you to work out egg
And ham.
and ham, or cheese
And egg.
and egg, cheese and ham, or ham and
Cheese.
egg, or ham and
Cheese.
cheese. Okay. Right, now you can see what they want. They want us to work out all the blue ones. So if you want to, you can work out all the blue ones and add them all up. That's what the question is all about. The different combinations. Or you can work out the red ones and do one minus it.
Red ones.
So there's two different ways we can do it.
I think we should do both ways.
Okay, let's just...
The red one.
Okay, ready to do the question now, folks? Okay. So you want to work out the blue combinations. You could do either one minus the sum of the red ones, which is quicker, or we could just do all the blue ones and work them all out and add them all up. Which way should we do today?
The red one.
The red one. So, probability of a, what's it called, different. Let's see if we can make this a bit brighter. Is that better? That's much better. Look at that. Beautiful. It's going to be good still? Okay. Probability of different sandwiches is going to be 1 minus the probability of getting the same. That's the idea. That's one way of working it out. So to work out the total of all the blue ones, we work out the red ones instead. And minus it. Right. Probability of getting the same. There we go. So it's going to be probability of an egg and
Egg.
okay, let's keep the color coding the same. And probability of a cheese, the probability of cheese, probability of a ham, and a ham. And because it's going to be all of those events. So this is one style of working out. So in order for us to work out the answer to the blue parts, we do 1 minus answer of the red parts, because altogether equals 1. So let's go for this question now. Okay, now we have probability of egg and egg. What's probability of my